Assalamu alaikum. Welcome to today's chemistry lesson. I am Maxi Miss from GN Education Center. How is everyone? I hope all of you are doing well and all of you are staying at home, taking all the necessary precautions recommended by HPA. So, I hope today's lesson is going to be interesting for you. And today we will be looking at ionic bonding. From the name itself, you would know that it's a type of chemical bond, right? Ionic bond. So it involves ions. So as a first objective, I will be looking at what ions are, how ions are formed, then how to deduce the structure of ions, calculating the number of subatomic particles in ions, how to define ionic bond, and some examples of ionic compounds. So first, look at what ions are. So what are ions? Have you heard of ions? Yes, ions are electrically charged particles, or you can say ions are electrically charged atoms or group of atoms formed when an atom loses or gains electrons. So when an atom loses or gains electrons, it will have a stable electronic configuration. So ions will have a stable electronic configuration or a stable electronic structure. You have already studied electronic configuration and stable electronic configuration as well, right? Do you know what a stable electronic configuration is? Yes, stable electronic configuration is if the atom has more than one shell. In the valence shell, in the outermost shell, it should have 8 electrons. You know what a valence shell is, right? It's the outermost shell. So if an atom has more than one shell, it should have 8 electrons in the valence shell. And if an atom has just one shell, it should have 2 electrons like helium. Helium has just one shell with 2 electrons and helium is stable, right? You must have heard of helium, right? Helium is a noble gas. All the noble gases are stable. Now let's look at how ions are formed. Are you all with me? So let's see. Take your notebook and you can just note this. Okay, note it down. So sodium Na, right? 2311. Now 2311. 23 is the mass number, right? 11 is the atomic number. You have already studied this when you studied atomic structure, right? And what will you take to write the electronic configuration? It's the atomic number, right? Atomic number, if you are asked to define atomic number, it's the number of protons in an atom, and the number of protons is equal to the number of electrons in an atom. So sodium, when you write the electronic configuration, it would be 281, right? It's 281. Now, when sodium forms sodium ion, there are 2 options for sodium to get a stable electronic configuration. One option is sodium can either lose the outer shell electron, that one electron in its valence shell, or sodium can gain 7 more electrons to obtain a stable electronic configuration. Which way would be easy? What do you think? Yes, sodium needs to lose this electron in the valence shell to obtain a stable electronic configuration. It would be easy, right? Since losing electrons involves energy, it would be easy for sodium atom to lose the electron in its valence shell to obtain a stable electronic configuration. So sodium will form sodium ion Na+. Why is it Na+? Because sodium atom is losing just one electron, right? And the electronic configuration of sodium ion would be 2, 8. I'm sure you would know why it is 2, 8. Right? Okay. Then you should also be able to draw the structure of sodium ion. So you have already studied how to draw the structure of sodium atom, right? But the difference between atom and ion is there is a charge in sodium ion, right? Have you noticed it? You must have, right? So let's draw the structure of sodium ion. So it's Na with square brackets, and then you can write a plus at the top. Very easy, right? Let's look at another example. Magnesium. Now where is magnesium in your periodic table? Magnesium is in group 2, right? 24, 12. And when you write the electronic configuration, it's 2, 8, 2. Right? So for magnesium, it would be easy to lose the 2 electrons in its valence shell to obtain a stable electronic configuration. Right? So magnesium will form Mg2+. Now you must have noticed that the number of electrons lost by the atom is equivalent to the charge of the ion. Right? Have you noticed it? You must have, right? So in sodium as well, sodium atom lost just 1 electron forming Na plus ion, and magnesium is losing 2 electrons to form Mg2+. And when you write the electronic configuration, it's 2, 8. You know why it's 2, 8, right? And when you draw the structure of magnesium ion, just draw square brackets, Mg and a 2+ at the top. I hope it's clear. Is it clear? Are you all with me? Okay. And then next, let's move on to how to calculate the number of subatomic particles in ions. You have already studied how to calculate the number of subatomic particles in atoms. Now ions are different, right? So in sodium ion, the number of protons is same as the number of atoms. So it's 11. Sodium atom also has 11 protons, and sodium ion, the number of electrons. Sodium ion is formed when sodium atom loses 1 electron, right? So it would be 10. And the number of neutrons would be 23 minus 11. Do you have your calculator with you? Take out your calculator and calculate. What is the value? Yes, it's 12. So basically, the atoms and ions will have the same number of protons and neutrons, but the number of electrons could be different. Okay? Now look at your periodic table and identify where sodium is. Sodium is in group 1, right? And then when you look at the electronic configuration, you would notice that in sodium atom, in the valence shell, it's 1 electron, right? And in magnesium as well. Magnesium is in group 2 of the periodic table, and magnesium atom has 2 electrons in its valence shell, right? Have you noticed it? So that means the group number decides the number of electrons in the valence shell. All the elements in group 1 will have 1 electron, all the elements in group 2 will have 2 electrons, all the elements in group 3 will have 3 electrons in its valence shell. And you would also notice that sodium as well as magnesium has less than 4 electrons in its valence shell. Have you noticed it? You must have, right? So all the elements in group 1, 2 and 3 are metals. Okay? Metals will have less than 4 electrons in its valence shell, and metals lose electrons to form positive ions. What do metals do to obtain a stable electronic configuration? Metals lose electrons to form positive ions, and these positive ions are known as cations. Remember the term, it's cations. Cations are positive ions. So is it clear? I hope it's clear. And then let's move on to another example. So it's oxygen 16 and 8. Now what is the electronic configuration of oxygen atom? You need to look at the atomic number, right? So when you write the electronic configuration of oxygen, it's 2, 6. Now what is the difference in electronic configuration between oxygen, magnesium and sodium? Think about it. You can write the electronic configuration and find it out on your own. In oxygen, you can see that it has more than 4 electrons in its valence shell. It's 2, 6. Now, again, oxygen has 2 options to obtain a stable electronic configuration. Oxygen can either gain 2 electrons or lose these 6 electrons in its valence shell to obtain a stable electronic configuration. What do you think? What would be easy? Which method would be easy? Yes, oxygen can gain 2 electrons to obtain a stable electronic configuration, and oxygen will form O2- with an electronic configuration of 2, 6. Is it 2, 6? No, right? It's 2, 8. Right? Yes, oxygen gains 2 electrons to make it 2, 8, and it's stable. Now let's draw the structure of the ion of oxygen. First you need to draw an empty shell, and in that shell you can draw 6 electrons. So these crosses represent the electrons. Now oxygen, when it gains 2 electrons, it forms the ion, right? So these dots, that represents 2 electrons from another atom that is gained by oxygen. Okay? So oxygen, the charge in the oxygen ion has a charge of 2-, the ion of oxygen 2-, right? And then you can write the symbol of oxygen. It's O, right? Is it clear? Are you all with me? Okay, let's look at another example. Let's take fluorine this time. Have you heard of fluorine? Yes, it's an element in group 7, right? So when you write the electronic configuration of fluorine, it's 2, 7. So fluorine, when it forms the ion, 1 electron is added to the valence shell. It would be easy, right? Just 1 electron will be added, and the ion of fluorine has a charge of F-, just F-, and the electronic configuration is 2, 8. You know why it is 2, 8, right? And when you draw the structure, draw a shell, draw 7 electrons, right? And then 1 electron showing that this is from another atom, and the overall charge would be minus. Now this F-, it is known as fluoride. Okay, fluoride is the ion of fluorine. Positive ions do not have special names. However, for the negative ions, there are special names. Like the ion of oxygen is known as oxide. The ion of fluorine is known as fluoride. The ion of bromine is known as bromide. And the ion of iodine is known as iodide. The ion of phosphorus is known as phosphide. So make sure you write down the special names on your own. Then try to deduce the charge. Try to draw the structure of ions and learn it on your own. Okay? So make sure you do that at home. Okay? And now I have looked at how to draw the structure of ions, how ions are formed, right? How to calculate the number of subatomic particles in ions, and then I will move on to ionic bond. Okay? Now, in an ionic bond involves a metal and a non-metal. Okay? Ionic bond is formed between a metal and a non-metal. Now, you have seen how metals form ions, right? And how non-metals form ions, right? So, metals, what happens to the metals when it forms ions? Yes, metals are losing electrons, right? So those metals transfer its valence electrons to the non-metals. So ionic bond is the electrostatic force of attraction. Remember the term, the electrostatic force of attraction between oppositely charged ions. Once again, ionic bond is the electrostatic force of attraction between oppositely charged ions. Okay? And as examples of ionic compounds, you can combine any element from groups 1, 2 and 3 with elements in 5, 6 and 7 to form ionic compounds. Like sodium chloride, it's an example of an ionic compound. Sodium is a metal, chlorine is a non-metal. Sodium chloride. Lithium nitride, lithium is a metal, nitrogen is a non-metal. Nitride, it's the ion of nitrogen, right? Aluminium oxide, aluminium is a metal, oxide is the ion of oxygen, it's a non-metal. So in an ionic compound, it would have a metal and a non-metal combined. So I hope you will know how to define ionic bond now. Okay? So in the lesson, in today's lesson, I have explained how to define ions, how ions are formed, how to write the electronic configuration of ions, how to draw the structure of ions, as well as what else? What else did I explain? Yes, I have defined ionic bond as well as calculating the number of subatomic particles in ions. So, as a homework, you can write down the names of at least 6 to 7 ionic compounds using your periodic table. You all have your periodic table with you, right? So, try to write down the formula of ionic compounds. Okay? So, in the next lesson, I will continue the next lesson with ionic bonding. Until then, stay home, stay safe. Thank you.